Okay, we're continuing section 3.2, solving algebraically, and this section is going to be by using the elimination method. So the main idea here is to first, we're going to multiply one of the equations, or we may have to multiply both, by a constant. That way we get our coefficients with opposite signs. So when we add the equations, we're going to eliminate one of the variables, and then we'll solve for the remaining variable. After we've solved, then we substitute back that value back into one of the original equations and solve for the other variable. Okay, so for example, if we had this system of equations and we wanted to solve by elimination, following the first step, we need to multiply equation 1 by -2 so that the coefficients of x differ only in their sign. The next step would be add the equations and solve for y. And then finally, we would need to substitute that value into the original equation and solve for x. So let's follow the steps. Multiply equation 1 by -2. Now I'm going to distribute, and I'll get -2x plus 4y equals -32. Okay, my second equation stays the same. And now, step 2 says add the new equations. Okay, so adding -2x plus 2x gives us 0. 4y plus y is 5y. And -32 plus 12 is -20. Okay, so we've just eliminated our x variable. Now we want to solve for y, so divide by 5, and y equals -4. Now that we have our y, we can substitute it back into one of the original equations. So let's pick the second equation. So we have 2x plus y, which we said was -4, equals 12. Now we want to solve for x. So if I add 4 to both sides, and divide by 2, x equals 8. Okay, I have a y and I have an x. Now let's check our answer. And remember, we check our answer by plugging it in to one of the equations. So x minus 2y would be 8 minus 2 times -4. And we need to see if that gives us 16. And it looks like it does. So it works for that equation. And just to be safe, I am going to check it for the other equation. So 2 times 8 plus -4 equals 12. 16 minus 4 equals 12. And it works. So we're good. Okay, here's an example of where I need to multiply both equations by a constant. So if I want to cancel my x's, what could I multiply 4 by to get 14? Well, there's nothing. And what if I wanted to cancel my y's, what can I multiply 10 by to get 35? And again, nothing. So I'm going to multiply the top equation by 7 and the bottom equation by 2 because I want to cancel my x's, and I know that 4 and 14 have a common multiple of 28. So when I multiply the top equation by 7, I'm going to get 28x minus 70y equals 56. And when I multiply the second equation by 2, I'm going to get -28x plus 70y equals -56. Hopefully you can see how I distributed the 7 to each of the terms, and I also distributed the 2 to each of the terms to get my new equations. Now the next step said we needed to add our new equations. So 28x minus 28x is 0, and negative 70y plus 70y is also 0, and 56 plus a negative 56 is 0. So, do we have a true statement? Does 0 equal 0? Yes. And because of this, we have infinitely many solutions. And again, just to reiterate, if we had a system and we got down to where the two numbers didn't match, then we would have no solution. Okay, I want you to pause the video and try this one on your own. Okay, now let's see how you did. So, hopefully you noticed that we could cancel out the x's if we multiplied equation 2 by 2. So once you do that, you're going to get 6x plus 4y equals negative 6. Now the next step is we need to add our equations. So we don't need to look at this equation anymore because we have negative 6x minus 5y equals 12 and 6x plus 4y equals negative 6. So I'm going to add those and I'll get 0x and minus y equals 6. Divide by negative 1 and I get y equals negative 6. Okay, so we found our y, and I'm just going to write it over here so that we remember. Now the next step is to substitute that into one of the original equations. So let's delete this and look at our original equations. And I'm going to substitute y in, and I'm going to choose the second equation. You could have also chosen the first equation. And now we're solving for x. So 3x minus 12 equals negative 3. Add 12 to both sides. And then divide by 3. Oops. And we get x equals 3. Again, it's important to check our solution to see if it's right. So I'm going to check by plugging in my x and my y into the original equation. This time I'm going to use my first equation, so negative 6 times x, which we said was 3, minus 5 times y, which we said was negative 6, and we'll see if that equals 12. So negative 6 times 3 is negative 18, negative 5 times negative 6, positive 30, and then we get 12 equals 12. So yes, our ordered pair 3, negative 6 is a solution to our system. Alright, I know this video was short and sweet, so if you still don't feel very comfortable with solving by elimination, email me and I will make another video of worked out solutions, or you can practice some of the odd homework problems in your book. But either way, please come Monday ready to ask questions.